In this video, we will solve a question on leontief utility function and how to find out the optimal consumption bundle. The question is, consider the utility function of a consumer given us is utility derived by consuming good x and y is equal to minimum of x comma y upon 300, where x and y are the two goods. For the first two units of good x, price of good x is 0. That means first two units of good x are free. Beyond that, price of good x is $1,000, price of good y is $1, and income of the consumer is $12,000. We need to find out the optimal consumption bundle of the consumer, and we need to find out the maximum amount of good x that he can purchase. So we have this utility function. Utility is equal to minimum of x comma y upon 300. This what we call the leontief utility function, or perfect complementary utility function, where the consumer consumes goods in a fixed proportion. Okay, so to give you an example what is meant by this, so let us suppose a consumer goes to a shop and he purchases a pair of shoes, let us say left shoe and a right shoe. Okay, and let us say he gets a utility of 10 utilities. Okay, if consumer only consumes or purchases left shoe, one left shoe and two right shoe, okay, again his utility will be 10, because this extra right shoe will not give him any satisfaction, because he consumes goods in a fixed proportion. That means one left shoe and one right shoe. Likewise, if he consumes two left shoes and one right shoe, again his utility will be same as getting from the left shoe and right shoe, because the proportion of consuming goods is here 1:1. That means with one left shoe he purchases one right shoe. Having extra left shoe or right shoe will not what we call increase the utility. Okay, this is the main essence of the leontief utility function. Now we have this case. So consumer consumes for every unit of good x, consumer purchases or has 300 units of good y. So this is our proportionality here. Now we are being given the additional information here. We are being told that, or let me write what we are being given here. Okay, so we have the budget of the consumer. So we have budget of the consumer is 2,000, or rather it is 1,200. Total income of the consumer. Price of good x is equal to 0 for x is less or equal to 2. We are being told for first two units of x, price of good x is 0. Okay, that is price of x is 0 if x is less or equal to 2. This is meant by this statement. For first two units of good x, price of x is 0. Having said that, then we have price of good x is $1,000 for x is greater than 2. This is being given the information. Also, price of good y, let me write it here to save the space, it is being given us is $1. Okay, we need to find out the optimal bundle that the consumer will purchase. And by the way, how do the indifference curves look like in case of perfect complementary utility function? We have x, y here, okay, with the given budget line. Okay, so our indifference curves will be L-shaped. Okay, so optimal bundle will lie at the point of kink, where x is equal to this will be the optimal bundle where consumer consumes both the goods in a fixed proportion. In our case, let us say it is left shoe, one left shoe or one right shoe. Okay, so if we have left shoe here, a right shoe here, so if we have one and one of both the goods, consumer will get a utility of 10. If consumer has two units, two left shoe, only one right shoe, we have the same utility because we are on the same indifference curve. Okay, so optimal point will lie at this kink. Okay, so I will not show it here because I don't have the space. This is enough. Now let us come to the question now. So we have this utility function, min of x comma y upon 2. This is the leontief utility function, which implies good x and y are perfect complements and are consumed in a fixed proportion there, but like I explained earlier. Okay, so for utility maximization, so let me write it here. For utility maximization, what we do in case of main function, we equate whatever is in the parenthesis. So we equate x is equal to y upon 300. Okay, so if we have a main function, let us say a main function of ax by, so our optimal for utility maximization, we equate whatever is in the parenthesis, that is ax is equal to by. That we have done here, which implies here y will be equal to 300x. Okay, this will be a point of kink. Now, having said that, we have the two cases. First case is when, and let me write it here, when x, that is consumes less than 2 units of good x. Okay, if x is less or equal to 2, think what will be the price will be in fact equal to 0. Okay, now let's construct the budget constraint. So price of good x times units of good x plus price of good y times units of good y should be equal to the income of the consumer. Okay, so this let us denote it by m. Now for first 2 units of good x, price of x is 0, so we have 0 times x plus price of good y is 1, that's being given us, so I will not write it. So we have y is equal to, income is 12,000. So y in fact will be equal to 12,000. Okay, now what will we do? We plug this optimal condition in this equation. Since y is equal to 300, and let me write it here, in place of y is 300, 300x is equal to 12,000, or x will be equal to 12,000 upon 300, 12,000 upon 300, which is equal to, yes, then 3 4 are, so x will be equal to 40. So consumer will purchase 40 units of good x, but we have assumed x is less or equal to 2, and we got the value of x is equal to 14. Is it possible? No, it is not possible. So our assumption, that is what I can say in this case, this is not possible, that when price of good x is less or equal to 2, consumer will consume 40 units of good x. So this cannot be our optimal consumption bundle. Okay, so for optimality, as I told you, first thing is we equate whatever is in the parenthesis, y is equal to 3x, then we plug it into the budget constraint. Holding it into the budget constraint gives us the value of x is equal to 40, but our assumption is that since x is less or equal to 2, but we got the value of x as 40, so this contradicts our assumption. That means this cannot be a utility maximizing bundle for good x. We don't need to care about good y, because since x is not in optimality, baad mein jaye y. Having said that, now second case is, and how do I write? Okay, so let me write it here. So we have, for second case, when consumer consumes or purchases goods more than 2 units. So let us see here, what will be the cost of first 2 units. So cost of first 2 units, as we know, since price of that will be equal to price of x into x, which will be equal to price of x is 0 for the first 2 units times 2, which will be equal to 0. So for first 2 units, cost of the bundle is 0. Now what is the cost beyond 2 units? Now cost no look yet. Let me see if I have any other cost beyond 2 units. what will be the cost beyond 2 units. Let us suppose consumer consumes 3 units, so it will be equal to price of good X times X minus 2. Why? Because let us suppose consumer consumes 6 units, so first 2 units are free, so it will be equal to 4 units here. That is what we have written here. So it will be equal, since price of good X beyond 2 units is 1000, so we write 1000 X minus 2, which will be equal to 1000 X minus 2000. Okay, so this is the cost of first, units beyond 2, cost of good X beyond 2 units. Now let's construct the budget constraint. So what will be the budget constraint? That will be price of good X times units of good X plus price of Y times units of good Y should be equal to the income of the consumer. Now Px into X, that is this thing. Okay, so that is equal to 1000X minus 2000 plus price of good Y is 1, so we will not write it, times Y will be equal to 12,000. So doing some basics, let's transpose it here. Itaron upper I had I missed here something. Your sorry, and we know that. Let me wrap. What is Y? Y is equal to 300, because this is the optimality condition. So in place of Y I can write 300X. कुछ तो गड़बड़ है दया. Okay, having said that, transpose this here. So 1000 plus 300, same terms, we can add them, it becomes 1300X. Okay, is equal to, so 12,000 plus 2000 is 14,000. Dividing both sides by 1300, so X will be equal to 14,000 upon 1300. These two got cancelled. We have 140 upon 30. Now it will be 13 ones are 13. 13 zeros are 0, something 10.12, I don't know. So this is the optimal consumption of good X, and you can see it is greater than this. This condition is not violated here, because we are getting X is equal to 14 upon 30, which is greater than 2. Okay, now what will be the cost of this is the optimal consumption bundle of good X and for good Y. So Y is equal to, plug this into this function, we have 300 into the optimal consumption of good Y. Okay, I'm really sorry I cannot do the calculation here. Okay, so this will be the optimal bundle for good Y. So X star Y star, that is optimal consumption bundle consumer would have, will be 140 upon 13, and yes, so we have then we have 3 4s are 12, then we have 3 1s are 3 3 4s are 12, 3 1s are 3. I am not sure whether I have done it correctly or not. So consumer will consume this amount of good X and Y. So this is the answer for the first question. Now we are being told find the maximum amount of good X he can buy. Okay, so what is the maximum amount he can buy? We don't need to care about the units of good X. We need to find out the condition. If consumer utilizes all his income on the purchase of good X, how much units of good X he will purchase. Okay, so for that, let me rub this out now. So what will we do here? I have to maximize units of good X. We will spend all income of good X. Okay, so we spend all income on good X. Okay, now what is the cost of first 2 units? So cost of first 2 units, that will be equal to price of good X times units of good X. That will be price of good X will be 0 times 2, which is 0. So first 2 units cost him 0 units. We know this. Okay, now what will be the income of the consumer after consuming 2 units? That will be equal to total income minus remaining. We need to find out the remaining minus the cost of first 2, which is 0. So his income will be 12,000 again, because he doesn't he is consuming first 2 units free. Now what is the units of good X beyond 2? So let me write it here. Number of units of good X beyond 2, X greater than 2. Let me write it here. That will be equal to total income upon the price of good X. Total income is 12,000 upon price is 1,000. So in 0 get zeros, we get 12. So first 2 units he consumes free. Okay, and after that he can purchase a maximum of 12 units. So total units, maximum total units of good X will be equal to 0. First 2 units, that are the free units, plus the 12 units, which will be equal to 14 units. So maximum he can purchase with his consumption, with his budget will be 14 units. First 2 free, and then extra 12 units. So extra 2 ABR I can. I hope I make myself clear in this video. Thank you.